So again, welcome to my YouTube channel, TensorFlow. So today in this lecture, we discuss the model agnostic method. So in this lecture, we discuss all around the model agnostic methods. So how, why, where, and when. All those points we cover in this lecture. So today is the first part of model agnostic method is partial dependence plot. So if you are first time on this channel, so please do the like, share and subscribe and press the bell icon. So when we will upload a new video, then you will get a notification. So today we will start the partial dependence plot and discuss all around the point of the partial dependence plot. So we will start the lecture. So go to on screen. Now we discuss the model agnostic methods, right? So in this method, we discuss in the three parts, right? First is we divide model agnostic methods in three videos. First is partial dependence block. Second is individual conditional acceptation. Third is accumulated, right? Third is accumulated local effects, right? ALE methods. So first we go to further, then we discuss some terms in MI. So we understand in better way. So first, what is the global and what is the local difference, right? So global normally focus over trends and average behavior of the model, right? On the entire dataset, right? Let's suppose this is my complete and entire dataset, right? But global completely overall trend and average behavior on the entire dataset, right? Entire dataset. But what is the difference between the local? Local is the simple. Local local analysis and interpretations that focus on specific behavior of the model for the individual instance, otherwise a small subset of the data. Let's suppose this is my entire dataset. This is the small subset of this data, right? This is the complete dataset, and this is the entire set. This is the local, right? So go to further, then we discuss some terminology of some terminology. Model agnostic. So what is the model agnostic? So normally explain how an AI and ML models make decision without caring which algorithm we will use. Right? So simple in the simple words, work for any machine learning model, right? So example, linear regression, random forest, XGBoost, neural network, या support vector machine. But these all models are black box model, right? Black box model, right? So first is why we need model agnostic methods. So in that case, many machine learning models are black box, right? Let's suppose we already give the example is random forest, XGBoost, neural network, and support vector machine, right? So these machines normally make high accurate predictions, right? So, but we don't know why they made a particular prediction. So in that case, for example, a bank and we try to apply for the loan. So, so my ML model give me only for response my loan is approval or rejected. So in that case, ML model give me the answer is rejected. But why my loan is rejected? So in that case, we use the model agnostic. So explain why my loan is not approval, why my loan is rejected, right? So in that case, so in all those model, we are not entirely uh, work on the internal structure, right? Because different model, different internal structure. Let's suppose if we use random forest in the random forest, hundred of trees, right? If we use the XGBoost, in XGBoost we have boosted tree. But if we use a neural network, then we use thousands of pairs, right? So why we and where we will use? So let's suppose use the bank is already I give the example is bank, and we find out the fraud detection, and we also use for the hiring process, and we also use for um, the fraud detection, hiring, and in one example is insurance, right? And we also use for the sometimes is healthcare, right? So now we go to the partial dependence plot. What is the partial dependence plot and how partial dependence plot is work? And we also discuss the how we exactly plot and how the any model work on the data and how the prediction and how the exactly plot of the partial dependence plot, right? So now we discuss the partial dependence plot. So today's main topic is partial dependence. Now we discuss the partial dependence plot means PDP, right? So in that case, first one is PDP is model agnostic interpreters used to show a relation between one or two features, right? This is very important for features and the predicted outcomes of machine learning. Let's have two features. This is X1, X2, X3, X4. Feature 1, 2, 3, 4, right? So what is it? One or two features relation. Let's suppose this is X1 and X2, two features, and relation between two features and predict outcome of the machine learning model, right? It averages outcome of affects all other features, right? This result affect other feature, third feature, fourth feature, right? So this is partial dependence plot. So how to plot a PDP? In that case, we discussed later, also using the coding and show the plot, right? So PDP only for use for regression or classification, right? So in that case, in if we use the regression, then average of prediction label is used, right? Label is important one. If we use the classification, then average of p class of interest is used, right? This is normal again. So when to use PDP? When we will use PDP, right? PDP is model agnostic, but if we use the global focus, then when you want to study the effects across entire dataset, when we have the entire dataset, right? And is the local dataset. Local मतलब small subset of dataset. Small dataset subset, right? So interpretability, when you want to understand the effect of one or two research on predictions, when we use only for understand the effect of two features, not other. Let's suppose this is one feature and two feature. We only for this use this feature, but effect on this feature, right? This is my second point. Third is model agnostic analysis. Normally, work with any ML models, right? Which type of model like black box and other, like tree-based means decision tree, neural networks, random forest, and SVM support vector machine, and all type of ML models, right? We use for partial dependent explore. Now is features relationship. When features are not strongly correlated, this point is more important. When features are not there, this is correlated means correlation. The correlation value lie between -1 and 1 if the strongly correlation means R value equals to 0.75 R less than equals to 1, then this is the strongly correlated. Otherwise is not strongly correlated, we can say, right? Then we use PDP is effective if features are strongly correlated, then PDP is not effective in that case, right? Now we learn the assumption of PDP, right? Which type of assumption? We have two assumptions. First is features independence, right? Assume the features of interest is not correlated. If features are not correlated with other features, let x1, x2, x3, x4. This is 4 features, right? So, not correlated. This feature is not correlated with x2. x2 is not correlated with x3. x3 is not correlated with x4. And x1 is not correlated with x3. All those types, right? With the other features, the correlation can lead the misleading insights, right? So if the features are correlated strong, then PDP is not working. But features are not strongly correlated, then PDP is work. So this is the first assumption. If the correlation is if the features are correlated, then our result is misleading due to the insights. Right? Second is average marginal effects. Right? So PDP always show the average effect across all instances. Right? This may obscure individual patterns. Right? Let's suppose this is 1, 2, 3, 4, and 5, and 2, 6, 8, 4, and 3. This is not a correlated. So if this is related, then we take the average. First we take the average and prediction basis on the individual pattern. Now the limitation of PDP. Which type of limitation we face in the PDP? Right? First is global interpretation, right? So average effects and may miss local variations or interaction specific of subset of data, because when we use a local, then we use a subset of the data, then this is a limitation, right? Then second is the feature correlation. I already explained. If features are correlated, then marginalizing over other features can produce unreliable result, right? In the, for example, salary predictions model for experience as a feature, if 0 is used for all instances and a set of an unrealistic dataset, right? I already explained in when we use discuss on dataset. And for third is computational cost. can be expensive to compute the large dataset. If we have a large dataset, yeah, complex model, then the computational cost is, I think, is more than this model is more expensive, right? And fourth point is 2D plot. When we are visualize the PDP on features versus label at a time, right? So this is a PDP is on basis of the 2D plot, right? Means hyperplane. Let's suppose this is X, this is Y, right? This is feature 1, right? And this type of plot, right? This type, this type, this type. Now we go on the code. So we discuss the code for partial dependence plot. So first we import the libraries, import numpys, matplotlib, pandas, matplotlib, all those important library for partial dependencies plot, right? Now I create a simple data frame with two features, right? Let's suppose x1 is one features and x2 is second features, right? X1 is one features and x2 is second features. And y is the label here target, right? Target variable. So in this, now I show the data frame data and print the head of the data. Head means only for show the five values. These five values, right? So now what we will do? Now we train a data. We already this data, simple data frame, we train, right? On the decision tree, right? Now we use the decision tree as a black box, right? So there is two features and y is the target variable. We already put there. Now we train the model, right? So in that case, model use decision tree regression and model fit is x and y. This is the trend. Now we for the partial dependence plot. So how we will generate a with respect to the feature one, right? In that case, a subplot of size. This is the size, and PDP is partial dependencies display from estimator. First is model, then use the x, and feature is 0. Why 0? This is feature 0, feature second, first, and other is feature in that case. So you can understand. Let's suppose this is my, so there I saw, let's suppose this is my features x1, x2, x3. This is my 0 index, 2, 1, and this is 2, right? This step is done, third step. And now this is features name, right? This is features name. We have two features, x1 and x2, and ax equals to ax. And set title is partial dependencies plot. This is the partial dependency plot of for x1. And now this is PLT show. Now we show the plot, right? So this is my 0, 5, and 10. This is my interval. And this is 2.5 and 5 below, right? So this is my x1 and this is my partial dependence, right? So again, I respect to the x2, right? So in that case, in general PDP for the features x2, again this is same, and we use there we use the 0 and there we use the 1 and other detail are same. So this graph is showing like that, right? Now we show both is together. That will work or not, right? So in that case, right? So both are together. How both are together work, right? So this is the partial dependence plot, and how this plot is look like, right? So I will try to show in small way. So this is my x vision on 0, 1, 2, 3, 4, right? So first 0 to around 1.2.5. So 0 to 2 value is around 0 on 10. This is my 10. This is small b. This is my partial plot. In that case, we have two features, right? One is the target variables, and we already saw and train the model is the we use the black box model is decision tree and two features and one target variable. So in that case, we use only for two features, and if you more practice, then you use the 3 and 4 and more and more, right? And train the model, then plot the partial dependence plot, right? This is my model, and both are together. We compare, right? Features 1 and features 2. Respect to the target variable. Target variable is y, and respect to the y, right? All those point is correlated or not, right? Assumption of PDPs, limitation of PDP, and when we will use PDP is agnostic, model agnostic. If the correlation is strongly, then we are not using PDP. If correlation is not strong, then we use the PDP, right? And PDP can be used PDP for regression or classification. In the regression, we use label is used, average of prediction label is used, and classification for the Y class of interest is used, right? And how to plot the PDP? First, we also learn on uh, dataset. So first we train a model, fit our machine learning model. So we use the decision tree. Here we use decision tree, right? Decision tree and choose a features. We use analyze both features x1 and x2 with respect to the y target, right? And replicate the dataset, right? Take all unique values of the chosen features and replicate the dataset on many times, because in features x1 and x2 we all values are unique, right? And replace features value, and each copy replace the chosen features on unique values, right? You already said. And predict and average, right? Predicted outcomes of all modified dataset and compute the mean of predicted value for each unique features value, and then we plot x-axis and y-axis. On the x-axis, we plot the unique values of the features, and y plot mean of the predicted value, right? So this is the simple lecture. We learn the individual conditional acceptation. So now we end of the lecture. So thank you for watching this lecture. So now we will meet in next lecture. Thank you.